This lab will be looking at Carnivora. Folidota is also included in this lab, which is the pangolins or the scaly anteaters, but there are no represented forms here today in lab. It's important to note because they are sister to Carnivora. So we have two suborders in Carnivora. We have Feliformia and Caniformia. So I will show you the families and the specimens that we have here today in lab. So starting in suborder Feliformia, the first and only family we have for this suborder is Felidae, which is our cats. So the first specimen that we have is Felis sylvestris. This is our domesticated cat. So we have a skin and we also have a skull. Note that in cats or in Feliformia, the skull is normally much shorter and more broad than the specimen that we have in Caniformia. I'll show you the teeth. So in all of Carnivora has pretty sharp teeth, and the carnassial pair, and they also have cylindrical canines, so we can see that there. And we can also see sharp teeth meant for shearing meat. The next genus that we'll be looking at in suborder Feliformia is lynx. So the specimens that we have is Lynx rufus, which is the bobcat. And then we also have a skin of Lynx canadensis. Differences between the two are definitely the size here and coloration of fur. We also have two skulls of Lynx rufus. The next specimen that we have is Puma concolor. This is our cougar. We have a skin and a skull for this. So this is much larger than the Lynx rufus skull that we just saw. The next genus that we'll be looking at is Lepardus. So we have two specimens in this. We have Lepardus pardalis, which is going to be our ocelot. And then we have Lepardus wieldii, which is our margway. The difference between the two would be the size. Lepardus wieldii is much smaller. The last skin that we have in suborder Feliformia is Panthera onca. This is our jaguar. And our last specimen is a skull of Panthera leo. This is our lion. So as you can see, this is the largest skull in suborder Feliformia. And I'll show you those teeth. All right, moving on to suborder Caniformia. The first family that we have is Canidae, so these are our dogs. Our first specimen is Canis latrans. This is our coyote. So we have two specimens for coyote here. We just have skins for these. The next species in Canis that we have is Canis lupus. So this includes the wolf, which I will show you here. So it's very large. It includes the wolf and our common dog. So we also have a skin for this here. And then we have these skulls for them. However, we've seen these previously in the first lab, but I will show them here. And I will also show the teeth. Genus that we'll be looking at in family Canidae is Vulpes. So these are our foxes. We have 3 species in Vulpes. Now we just have the skins for these. So these 3 here are Vulpes vulpes. This is the red fox. However, note that there are many different color morphs for this species. The next species that we have is Vulpes macrotus. And the last species we have is Vulpes lagopus. So this is our Arctic fox. This is our kit fox. And we can see the color differences there. The next family that we have in suborder Carnivora is Ursidae. This is our bears. I'll show you these skulls first. It's good to note though that we're only expecting that you know the skulls to genus. So I'm going to tell you the species, but you only need to know that they are Ursus skulls. Our first specimen is Ursus maritimus. We do not have a skin for this. This is our polar bear, and it is the largest skull that we have. The next is Ursus americanus. This is our black bear skull. And the last Ursus species that we have is Ursus arctos, which is our brown bear. The last thing I'll do is show you the teeth for all of these. In Ursus, because of their diet, because they're omnivores, they have much flatter teeth. They're not as sharp as in comparison to the other carnivorous species that we have in lab today. We have 2 skins. We have Ursus americanus, which again is our black bear here. And then we have Ursus arctos, which is our brown bear. So color differences between the 2. The next family that we are looking at in suborder Carnivora is Procyonidae. These are our raccoons. So we have 2 skins, or 2 species for these skins. We have Procyon loader. This is our raccoon. And we also have Bassaricus astutus. And this is our ringtail. The next family that we're going to be looking at is Memphitidae. These are our skunks. So we have 2 specimens. The first being Spilogale gracialis. This is our western spotted skunk. We also have skulls. One thing to note is that the scars on the top of the skull that you're seeing are caused by nasal nematodes or some sort of parasite, and they are not diagnostic to this this specimen. So there are others that are also infected with this. The next species that we have is Memphitis. So this is our striped skunk. It's much larger than the western spotted skunk. And we also have skulls for these. So also larger skulls than the Spirogaly. And we're also seeing the sharp teeth for shearing meat. The next suborder that we're going to be looking at is family Mustelidae. These are our weasels, badgers, otters, and wolverine. So the first species that we have is Mustela erminia. This is our ermine. One thing to note about this species and the next species of Mustela is that we have a color morph going on. So the white color morph is for the winter and the brown is for the summer. But we also have sexual dimorphism in size happening. So that is why members of the same species are much different in size. One other thing to note about the ermine in comparison to the next species is that its tail is much shorter than Mustela frenata. So we have the long-tailed weasel next, which is a different species in Mustela. But the key characteristic between these two is the length of their tails. So I'll try to give a... We also have skulls for these. So here are the skulls. Again, the scars on the top of the skull are caused by some sort of nematode or parasite. And then I don't know if I gave the size. We also have a frenata skull. The next species or specimen that we have in family Mustelidae is Mustela vision. So this is our American mink. We have a skin and we also have a skull. And then I will show you the teeth. The next species that we have is Martes americana or Carina. You can say whichever one they are. Recently, they were split into different species by geography. So that's why I'm saying you can do whatever you want because we don't know what species this is. We also have skulls for this. So this is Martes. This was Mustela vision. So you can see that it's much larger. And we'll show you those carnivorous teeth again. The next specimen we only have a skull for. This is Picanha pennati. This is our fisher. One thing to note about this is that it has a very dramatical sagittal crest. The next specimen that we have is Gulo Gulo, which is our wolverine. So we have two specimens. We have a smaller and a larger wolverine. And then we also have the skull of the wolverine. The next skull we have is Lontra canadensis. This is our river otter. We only have skulls for these, and we also only have a skull for Enhydra lutris. This is our sea otter. Then I will go and show you the teeth. All right, the last specimen that we have in family Mustelidae is Taxidae taxus, and this is our American badger. So we have a skin and we also have a skull for our badger. I will not be able to show you the teeth. The next family in suborder Carnivora is Phocidae. So this is our seals, and we only have one specimen in this, and it is the skin of Phoca vitulana. So I'll give an outlook. This is our harbor seal. So again, we only have his skin for this. The next family that we have is Odobenidae. The specimen, the skull that we have is Odobensis rosmaris. So it is very large. And you can see where the tusks come out. This is our walrus, if I did not say that. And the last family that we have in suborder Carnivora is family Otaridae. We have one specimen. This is Xolophus, which is our sea lion. And the unique thing about Xolophus is that it has unicuspid teeth. So they're very cylindrical, sharp, pointy. So that is a very diagnostic feature because no other skulls in lab today have that. And that's it.